in the Do Now today, we had a problem that has a challenge. And the challenge is going to be obvious as soon as we do just a little bit with the balancing. So I'm going to balance this equation exactly the way I would if I had never seen it before and I didn't know what I know now. So I'm looking first of all at the carbons. So I look at the carbon and I see that it has a subscript of 6, and I go over to the right side of the equation right here and I see that there's carbon in carbon dioxide. So if I put a 6 as a coefficient, that balances my carbons on both sides of the equation. So the next thing I want to do is look at my hydrogen. And the hydrogen here has a subscript of 6. If I go over to the water, what I'm going to do is I'm going to see that I have a subscript of 2 on hydrogen, and 2 divided into 6 is 3. 6 being the subscript of the hydrogen, and 3 now being the coefficient over here. So 3 times 2 is 6, giving me the ability to have a balanced hydrogens. Now that my hydrogens and my carbons are balanced, I can now go back and look at the oxygens. So I'm going to add up my oxygens on the right, and I'm doing that because I know that with oxygen having a subscript of 2 right there, that is a problem, because over here this oxygen is an odd number because of the coefficient of 3. So I can't change that. The ratio between carbon and carbon on both sides, here and here, is set at 1 to 6. The ratio of hydrogen to hydrogen is set, and now my ratio of the hydrogens here to the hydrogens on the other side are 6 to 6. And that ratio requires that I have a coefficient of 3. So those guys are fixed and I can't do a thing with them. So now I'm going to figure out how many oxygens, how many oxygens do I have? So I look first of all here, and I see I have a subscript of 2 times 6 to give me 12. On the oxygen here, I have 3 times 1 to give me a total of 3, and when I add them up, I have 15. You cannot take 15 and make that balance with a 2, which is this guy. Oh, it came apart. Doggone it. Okay, there we go. You can't make it balance with that 2 subscript, because any number you do is going to be an odd number, or an even number. And the oxygen is an odd number. It's 3 because of the coefficient over at the water. And if I can keep from dropping my pen again, we'll get through this video. So, at any rate, that's what we have to worry about. So this oxygen, because of that coefficient, this oxygen becomes 3, and I can only balance with multiples of 2. I'm never going to get to 3 with multiples of 2. So what some creative people have done is said, all right, I got 15 oxygens, or 15 oxygens on the right, and I want to get a coefficient for my oxygen, so on the left. So I'm going to take my 15 and I'm going to divide by 2, and that gives me 7.5. So let's make this 7.5. Well, that's fine, except you have to have an even number, a whole number. So how can I fix this? I'm sorry, I didn't understand what you said. What are you trying to accomplish? Or what are you trying to do?
I'm just trying to like make it so that both even on the outside and both the side.
You're saying you put 7.5 on 7.5?
You put 15 on the outside and on the left.
Uh-huh.
But you make them both different.
Okay, but if you're going to do that, you got to worry about one very, very important fact. And that is that this ratio here of all these guys is a 1 to 6 to 3. And how do I get that? So if you're going to double this guy and you double this guy, you're dead, because everything else is messed up. And the basic reason for that is that this 1 and this 6 and this 3 are a fixed ratio of this substance to this substance to this substance. And the way I write that is like this. These guys are connected with the coefficients that I've used to start with. And because of that, I was stuck without changing, here we go, without changing this, this, or this independently, I would have to multiply everything by the same number no matter what I do. Now, it just so happens in this particular thing, if I keep my blues together and I double this number, 2, also, okay, I'm multiplying everything by 2, I'm going to multiply the whole shooting match by 2. Okay. Good. I had to make sure that that's what you meant. So you have another option here. You can get rid of this 7.5 and go back, cross out the blue numbers, and multiply those blue numbers by 2. So that would be 2, and this would be 12, and this would be 6, which is still this original ratio of 1 to 6 to 3. Does everybody know when you have a ratio like this, you can multiply everything by the same number, and it's still the same ratio? Okay, it doesn't change the ratio. So because I can do that, I figured out that that ratio has to stay put. And now I'm going to add up some new numbers. I'm going to take and add up my 12 times 2. 12 times 2 because this is my new coefficient, and my oxygens have a subscript of 2, so that's going to be 24. And then I'm going to multiply my 6 by 1, and that gives me another 6 oxygens. And now I have a total of 30. Now that divided by 2 is 15. And that's how I get my 15 coefficient. Okay? These are the problems that we did for last night's homework. I'm just going to show them for a short time. If you want to see them for longer, what you need to do is just stop the video to copy down what you need. So here's our two problems 2 and 3 that we did, and the balancing there. And the next one is from page 304, 71A and 71B. And I did the logic on my balancing on this one that I like to use is we have iodine here. This is iodine and this is iodine. The way it was written, it's not totally obvious. And the just a moment, I'm going to get a pointer. Okay, you might say, okay, that 3 is the coefficient of the iodine, which is I2 because it's part of NOON 17, which we talked about yesterday. So this coefficient comes from the suffix of the, or not the suffix, but the subscript of the iodine on the right side of the equation got moved over to the left. And the subscript of the iodine on the left got moved over to the coefficient for the aluminum iodide. Because of that crisscross that I did, you can't miss on the balancing of the iodines, because 3 times 2 is the same as 2 times 3. Okay? So in balancing this one, that's where I started. And then once I had that ratio set, I could go ahead and balance the aluminum. And as a general strategy in balancing your equations, if you have one guy all by himself, you want to balance him last. Don't mess with balancing him until you've got the other stuff taken care of. And that's the only one that's not balanced. So that's the strategies that you want to pick up for yesterday's homework. Okay, today we're going to do what I call counting atoms the easy way. And everyone in class today gets the handout of what I have here with all the answers on it. But I'm going to show it to you in such a way that you don't see any answers until we've had a chance to give the rule a try and make sure that we understand the rule. So Armin's going to tell us for potassium chloride, which is on the left here, how many potassiums do I have? With the 3 out front? Yeah. Okay, good. 3 potassiums. And how many chlorines do I have? Excellent. Okay, so this is pretty easy. It's a simple rule, and I think most of you will have no trouble with it. Ava, would you please tell us for manganese monoxide, how many manganese do I have when I put a 2 out front of the molecule?
2.
Excellent. And how many oxygens?
2.
Yeah, pretty easy, huh? Okay, and next up, let's have Muriel. And Muriel, could you tell us for, already showed you one, what's the potassium?
7.
Uh-huh. And what's the oxygen?
7.
And the hydrogen?
7.
Okay, pretty easy, huh? No problem there. All right, now let's go and look at our second rule that you're going to be using, which allows you to see how to put things together when you have a subscript on the atoms. So if an atom has a subscript, the coefficient multiplies every atom's subscript. Coefficient is the number out front. So, Kenneth, Chung, okay, could you please tell me with a coefficient of 3, which is this guy, what is the subscript of oxygen?
6.
No, subscript of oxygen.
Oh, 2.
Okay, subscript of hydrogen. Okay, now, with that, how many hydrogens do I have?
6.
Excellent, because 3 times 2 is 6. And for oxygen, how many oxygens do I have? 6 again. Okay, so this guy gives us the way to find out how many of each atom we have. And we're going to go to potassium chromate. That's the chromate ion, and it's with the potassium. And Michael, could you tell us for potassium chromate, how many potassiums do we have?
6.
Good. And how many chromiums?
3.
Excellent. And how many oxygens?
12.
12 it is. Okay, so this is, again, a relatively simple one, especially after you understand what the rules are. And Raven, would you please take and give us what you have for potassium sulfate, this last one here. How many potassiums?
8.
Okay. And how many sulfurs?
4.
Good. And how many oxygens?
16.
16, because of the coefficient. Okay, so what we do is we simply, and I'm going to leave these open so somebody at home could actually see them. And let's go down and go for the last rule. This is the one that's going to be the most difficult. If there is a subscript after a parenthesis, it multiplies everything inside the parentheses, but not anything outside of the parentheses. So let's look at iron sulfate. And actually this is iron 2 sulfate is the way we would say the name of this guy. And Eliza, would you please do this one? Okay, Eliza, what do we have for the total number of irons? Eliza? And I'd like you to tell me now, how many irons do we have in this molecule? If we have, or in 5 of these molecules, is probably the better way to say it, how many irons do I have? Excellent. Okay, you understand that much. Now let's look at the sulfur. For sulfur, we have to also put this guy into the multiplication. So we have how many total sulfurs in 5 of these molecules? Okay, 5 times 10, or 5 times 2 is 10, times the subscript on the sulfur of 2, or of 1. So 10 times 1 is 10, and you got that right. Very good, Eliza. And now let's look at the oxygen. What do we have there? It's a big number. Okay, let's do it in order. 5 times 2 is, okay, times 4. There you go. There you go. It's exciting to be able to do it, isn't it? Yeah, it is. Okay, next one, manganese sulfate. All right, that goes to John. Okay, John, you ready? How many manganese do we have? 3, good. Because this 2 does not affect the manganese. It stops at the end of the or at the beginning of the parenthesis because it's on the end of the parenthesis. All right, how about the sulfur? Nope. Good, it is 6. All right, and how about our oxygens? Great. What he just did in his head was 3 times 2 is 6 times 4 is 24. Very good. And the last one, I think we have one more of these. Yeah, we do. Ah, this is going to be a fun one. So let's go to Pavel. You get to do this one. Can you see the numbers okay from back there? Okay, why don't you move up a little closer so you can see? Yeah, because you need to be able to see the subscripts. Here, temporarily, why don't you sit right up here? Okay, so how many coppers do I have?
3.
Excellent. And how about the chlorines?
9.
No.
3.
No.
6.
You're guessing. Okay, do the numbers for me. 3 times 2 is?
6.
Times 1?
6.
6. Okay, so that's your chlorines. And now let's do the oxygens.
6.
That was the chlorines.
Hold on.
Oxygen has a subscript. Okay, good. And what he just did in his head is 3 times 2 is 6 times 3 is 18. And that's how the subscripts work when we have parentheses and when we don't. Okay, thank you for watching.